Now that you're an expert on electricity and electric flow, let's talk about circuits. What are circuits? Are there different kinds of circuits? So first, let's talk about a simple circuit, or the most simple circuit you can create. Electric charges, or electrical energy that you know about, move in a looped circular path called a circuit through wires. So here's a diagram down here, and as I talk, refer to this diagram. So the parts of a simple circuit include a power source, and it could be a battery, and in our case we will be using batteries in class. At least one conductor, which in our case will be copper wire. It could include a switch, which either completes the circuit or opens it. So the switch, if it's open, the circuit is not complete and the load does not light up, or the light bulb doesn't light up, Normally, circuits have resistors. Now, when we are using our wires in class, we don't see the copper very much. We see the copper at the ends of the wires, but around the wire is rubber. That's the resistor that holds the electric charge in, so it doesn't escape and shock you or cause damage. To measure electricity, we know that you need to use units. Volts measures the electric force provided by an energy source. So our energy source in class is a battery. We will be using D batteries, which gives off about 1.5 or 1 5/10 volts of electric force. The current, or the flow of electrons, measures how much charge moves past a given point each second. This is called ampere or amps. I'm sure you've heard of that word before. Let's move on to complex circuits. This diagram shows a parallel circuit. It's more complex than just the simple circuit we've made in class. Parallel circuits have more than one pathway for electricity to flow. In a parallel circuit, not all the pathways or branches have to be on at the same time. So in this example, the electricity can flow and light up this light bulb, but if one wire is disconnected here, this light bulb won't light up. And the same goes for the opposite. This light bulb can be lit and this one doesn't have to be. We will be experimenting with that as well in class. So electromagnets. As you can see in the picture here, this is an electromagnet. You need a power source, a resistor or a rubber band, a conductor, which is the copper wire, wrapped into a coil around a nail. So this creates an electric current or an electromagnet. Electromagnetic magnets are used in many objects like motors and doorbells and sound systems. In motors, the electromagnets turn on and off rapidly, causing the magnetic fields to attract and repel each other. The result is that the rotating parts of the motor start to spin, therefore running the motor. The electrical energy made in the electromagnet transforms into mechanical energy. So motors can move all sorts of things, from cars to toy cars to huge locomotives, a whole bunch of different things.
The circuit is made up of components linked to each other by electric wires. The objective is to transmit the energy contained in the movement of a large number of electric charges to a receiver. This movement of electric charges is called an electrical current. An electrical current flows if at least one of the components of the network is a generator. Furthermore, the circuit must form a closed path through which a charge can flow and return to its network. The opening and closing of the circuit can be controlled with a special component, the switch. Disconnecting a conductor anywhere along the circuit has the same effect as opening the switch. Circuits come in all sizes and shapes. The loop of the circuit can be only a few millimeters in the case of integrated circuits, for example, or several kilometers for the electrification of a train. In every case, there is a path for the return of the current. To standardize the representation of electric circuits, a symbol is associated to each Here is the standard diagram of the LSO circuit. Let's imagine now that we want to connect the second light bulb. We can put two light bulbs on the same branch, or we can put them on two separate branches. In the first case, say the light bulbs have been connected in series. They have one terminal in common, and the current that flows through the first light bulb is the same as the one flowing through the second one. If the filament in one of the light bulbs is broken, the current is blocked from the whole branch, and the other light bulb is turned off. In the second case, the light bulbs are set up in parallel. The charges can take two different paths, and the current in each light bulb can be different. If one of the light bulbs is faulty, the other one can choose to light up. Lamps in a house, like trains on the same railway line, are connected in parallel. An electrical circuit.
So there's the summary of more in detail of what I told you about circuits. Fill in your notes completely, and we will be experimenting with all of these things in class.